Newton's law of gravity passes its greatest test ever.
The law of gravity proposed by Isaac Newton more than 300 years ago has just been confirmed on a scale never before tested.
Scientists observed the movement of distant galaxy clusters, scattered across hundreds of millions of light-years in the universe, and discovered that gravity behaves exactly as Newton predicted, and as Albert Einstein refined in his theory of general relativity. According to Newton's law of universal gravitation, the force between two bodies is proportional to their mass and inversely proportional to the square of the distance separating them. This simple rule continues to hold true even at enormous cosmic distances, as confirmed by a recent study led by cosmologist Patricio Gallardo of the University of Pennsylvania. When we look at the universe, however, a great enigma arises. Galaxies rotate too fast, light bends more than expected, and clusters that should disperse remain united. If we consider only the ordinary matter we can see, stars, planets, dust, and everything that forms galaxies, these movements don't make sense. Something else is at play. There are two main explanations for this problem. The first is dark matter, an invisible substance that doesn't emit light, doesn't reflect light, and only interacts with the rest of the universe through gravity. It is estimated that about 85% of all matter in the cosmos is dark matter. The second possibility is that our understanding of gravity is incomplete and needs adjustments on very large scales. To decide between these ideas, Gallardo and his team analyzed about 686,000 galaxies located between 5 and 7 billion light-years away. They measured how the clusters move towards each other using a phenomenon called the Sunyaev-Zel'dovich kinematic effect. This method takes advantage of the cosmic microwave background radiation, the first light that traveled freely through the universe after the Big Bang.
When this radiation passes through hot clouds of gas surrounding moving clusters, the photons undergo small changes. By measuring these changes, scientists can calculate the exact speed of the clusters. With these speeds, it is possible to test the intensity of the gravitational force at large distances. If gravity needed to be modified, it should weaken more slowly with distance, becoming stronger than predicted on enormous scales. However, what the researchers observed was the opposite. The gravitational attraction decreases rapidly, faithfully following Newton and Einstein's inverse square law. This means that classical theory continues to work perfectly even at the largest scales ever tested. The result reinforces the idea that dark matter is the most likely explanation for the strange behaviors we see in the cosmos. We still don't know what it's made of, but the study shows that we don't need to change the laws of gravity to explain what happens. As Gallardo said, it's remarkable that a law proposed in the 17th century still holds up in the 21st century. This research, published in the journal Physical Review Letters, represents the largest test ever conducted of gravity on cosmic scales. It doesn't solve all the mysteries. The nature of dark matter remains one of the greatest challenges of modern physics, but it confirms that our fundamental theories are surprisingly robust. Gravity, as always, continues to attract and fascinate us.